Yeah, very good morning to everyone. Morning. Fine. We're going to start now. So again, I'm going to show you what we have covered yesterday and also to let you know what we're going to do today, right? So yesterday we have learned about DNS administration, right? So basically, the main objective in this DNS administration is for you to know how you can configure DNS in Solid Server. So for you to configure DNS in Solid Server, right, from the management server, you need to follow the hierarchical object model of DNS, right? So you need to enroll the server. You need to enroll the server into the management server, and then most probably you will use smart architecture, right? Because you're going to manage multiple DNS server from the management server. So you will enroll the DNS server into the management server, and then after that you will create smart architecture. So you choose a smart architecture that you want, and then you're going to actually add the DNS server as a member of the smart architecture, right? And assign the role. The role have to be chosen manually, right? In the smart architecture. Right? So once you have add all the member in the smart architecture, then whatever configuration for DNS, you will do it in the smart architecture. So basically the smart architecture is the template, right? Yeah, the template of the architecture. So you do it, whatever thing you configure on the smart architecture template, right? It will be pushed down to all the member accordingly to its role. Isn't it? Yeah. Okay. Unless there are some specific setting, you might want to do it at the server, the member level, because you want it to be different for different member, like the forwarder, like the source IP address to use for zone transfer, for recursive query, right? Yeah. So those normally you have to set at the member level because it have to be different on each member. Fine? Yeah. Now, of course, in the DNS, to manage the DNS configuration, right? You will need to create you will need to create zone if you're going to use the DNS server as an authoritative server. So if you want to use the DNS server as an authoritative server for a particular zone or for zones, you will need to create zone in the DNS server. So that will be the authoritative zone. Are you clear with that? Can follow? Yeah. So, and then of course, in the zone, right, you're going to create resource record. Fine? Yeah. Now, of course, if you do not use authoritative server, maybe you are using the DNS as a recursive server. So if you're using DNS for recursion, then of course you don't need to create zone. Okay? So you will need to turn on recursion, and you might need to set forwarder. Are you clear with that? Right? So those are again another feature you have in DNS recursion. You can have both authoritative zone and recursion in the same DNS server. You can. The bind engine support it, so you can have both. Okay, that right? Yeah. So those are things that we actually really talk about, right? Using DNS. Fine. Now, of course, you also have reporting in DNS, right? yeah, you also have reporting, statistic, analytic in DNS. Those are very good for monitoring. Is okay, right? Yeah. So those are things that can they will be able to help you to look into the DNS traffic usage. Look into the status of the DNS, right? Server, and then look into the traffic pattern so that you can identify a normal traffic pattern, and you will be able to identify the malicious domain or the malicious client, right? Using those analytics. Oh, so yeah, so those are part of the monitoring, report and analytics. Right. Then we covered integration. See? So in Solid Server, you can have integration among the three services. Right? Yeah. Yesterday we already covered the integration between IPAM and DNS in both direction. So basically, you can have replication from IPAM to DNS. You can have replication from DNS. Sorry, let me repeat. Yeah, you can have replication from IPAM to DNS. You can have replication from DNS to IPAM, both direction, right? Yeah, and you know that it's very flexible, right? You can turn on replication or you can turn off. And even when you turn on replication, you can choose the replication at the object level, right? So you can have a replication only for a particular subnet. Yeah. So you can pick which is the subnet in IPAM you want to replicate to DNS. See, so you can choose a replication at different object level, and then you can replicate to different DNS server, right? Because when you turn on the replication for IPAM to DNS, right? You need to choose the DNS server, right? So that the replication so that any changes in IPAM, the changes will be replicated to the specified DNS server. If you use smart architecture, then you have to specify the smart name, not the server name. See? Yeah. So you have all this flexibility. To configure the integration, you have to use the advanced property of the object, right? So the replication between the services are configurable on each object using the advanced property. Or IPAM to DNS advanced property, or DNS to IPAM advanced property. So make sure you go to the advanced property of the object and set the replication, set the integration property. Okay with that, right? Yeah. Okay, so these are what we actually covered yesterday, right? So today we're going to look at DHCP, right? Our focus is on DHCP, right? Yeah. If can, maybe we can go to export import, right? Then we will have a shorter day tomorrow. Okay with that, right? Yeah. So to get target, let's look at DHCP, right? Okay, fine. Any questions so far? Anything? Any question come into your mind? No? Okay. If not, we're going to move on to the next. We're going to move on with DHCP now. Let me see here. 14. Fine. Now, let's look at DHCP part 1. All right. Now, part one, basically is just to show you how you can set up DNS, DHCP, right, in Solid Server. So that actually it's the same, just like DNS, right? Before you can manage the DHCP server from the management server. So on the management server, you need to enroll the DHCP server, right? And then you're going to use a smart architecture to manage them. Okay, so that is what we have learned about in DNS. We're going to see that in DHCP also. No different. Okay, so yeah, server management for DHCP. Now, exactly the same like DNS. Okay, in every solid server, you have a DHCP engine. The DHCP engine will actually provide listing IP address to the DHCP client on the network, right? So on the management server, on the management solid server, yes, you have a local DHCP engine, but normally you wouldn't be using it because you're using it as a management server. You might not be using it. You might not use the local DHCP server engine. Okay, but if you want it, you can use it, right? And you can make it functional, operational, to list IP address to the client. Okay, right? Now, of course, using the management server, yeah, you can manage the remote DHCP server. So these are the remote solid DHCP server, and you have a local DHCP engine. It's an ISC engine, DHCP ISC DHCP engine. Fine. Using the centralized management server, solid server, centralized management solid server, you also can manage other vendor DHCP server. Are you clear with that? Right? Now, the management server will do the same thing, which I already emphasize every day. If you're going to manage the DHCP remotely, right, from the centralized management server, when you log into the management server web interface, whatever DHCP you configure, right, it will be stored in the local management database of the management server, and then the configuration will be instantly pushed to the remote DHCP server, updating the config file on the DHCP server. So you have the DHCP daemon.conf file. The DHCP daemon.conf file are on the DHCP server. So any changes that you make on the web UI, the first thing you go to the management database, and then from the management, once it's updated on the management database, the management server will push the changes to the remote DHCP server, updating the config file there. Right? Same thing, the synchronization is two-way. If you go to the config file and make some changes, right? The changes will be automatically synchronized to the management database, right? Every 10 seconds. So it means that the management server will pull the update from the remote DHCP server every 10 seconds. Okay, yeah, so it's two-way. Okay. Now, in order for you to manage the DHCP server remotely, you need to enroll the DHCP server to the management server, right? Just like DNS, you have a service account. You have a service account for DHCP. So that is a service account name. So this is a service account the management server used to log into the DHCP server remotely and manage the DHCP engine, manage the config file of DHCP engine. Okay, that right? Yeah. So same thing, treating for the enrollment process, right? Treating. You have a service account for DHCP, right? You need to enroll the DHCP server into to the management server. And the first time when you enroll, you need the SSH admin account of the DHCP server. Because they need to attend the first time when you enroll, they need to log into the remote DHCP server using admin, right? For the enrollment process, the first time, right? Then after the enrollment, subsequently, they will use the service account to log in to manage the DHCP engine. So that's why the diagram show you here. So when you add the DHCP server in the management server, the management server will authenticate to the remote DHCP server using the admin, SSH admin account of the DHCP server. Okay, then they will activate the service account for DHCP and generate a random password. So the generated random password of the service account will be sent by the remote DHCP server to the management server. So the management server will store the random password in the management database. So once the management server have the password of the service account, then subsequently to manage the DHCP server engine remotely, they are going to connect to the remote DHCP server using the service account, right? And the recorded password, the recorded password in the management database. Okay, then, right? So same thing here, as I mentioned. When you in the management server, when you manage the DHCP from the management server, whatever configuration you do on the DHCP server, it will be the configuration will be updated in the management database. Okay, that right? And whatever changes that is updated in the management database will be instantly pushed to the remote DHCP server, right? And the remote DHCP server engine config file will be updated accordingly. So just like in the management server, you add a subnet, right? So when you add a subnet, which is a scoop, okay, yeah. So the example, the scoop, you are creating a scoop in the DHCP server, right? So the scoop will be stored in the management database, and then it will be pushed to the remote DHCP server, by updating the config file on the remote DHCP server. So that's why you can see the DHCP daemon conf file will be updated with the scoop. Okay, yeah. Now, right. So this will be the configuration of the DHCP engine now, right? So that the scoop now will be available on the network to serve the client on the network. The protocol they use for the synchronization is HTTPS. So they use the web service. Yeah. So this is actually from this is actually only showing you the synchronization from the management database, from the management server to the remote DHCP server. Are you clear? Yeah. Now, for you to actually enroll the server, it will be exactly the same like DNS, right? So you go to DHCP now, you go to this DHCP icon on the sidebar, and then you select server, and then you will be able to add. Currently, there's no DHCP server. You can click on add, and you can choose a server, and the server can be Efficient IP or other vendor. Fine. So you choose Efficient IP, or you give a name, any name you like. The name might not be important, but at least must be meaningful. The management IP of the DHCP server, right? And then the admin login password. Clear this? Yeah. So once it's done, you can see the DHCP server is added, and they will be in sync. So basically, they're going to pull the config file from the DHCP server into the management database when you enroll the DHCP server. So they pull the configuration from the config file of the remote DHCP server to the management database of the management server. Okay with that? So synchronization. So synchronization might take a few seconds. So you might just wait for a few seconds. Yeah, then it will become synchronized. Oh, okay, good. So yeah, so you will be able to see the same thing like DNS. You see the version of the DHCP engine. Yeah, and whether it's connected, whether it's reachable, which status will show you whether they are reachable by the management server, right? And whether the configuration are in sync. In sync means whatever thing in the management database is in sync with the config file on the DHCP server. In sync, right? Okay, now as I mentioned, using Solid Server, using the management Solid Server, you will be able to manage efficient IP DHCP server. You also will be able to manage Microsoft DHCP server, other vendor, just that you require additional license or the multi-vendor service management license. Right? Again, please read the user guide. What are the restrictions? So there are some restrictions that there are some restrictions if you are using Microsoft DHCP server, or certain things cannot be managed. You can also download the efficient IP DHCP engine. So let's say you can download the installation packet. You can download the installation packet of efficient IP DHCP engine. So you download the installation packet of the DHCP engine of efficient IP, and then you can install it on your Linux server. So if you do this, you can also manage the DHCP server from the management server. Okay, and there is no restriction. Right? Yeah. So if you want to use your own server as a DHCP server, you can consider using the installation packet from Efficient IP. Right? Yeah. The only thing is you need license for that. Okay, so you still need the NVSM license. Okay, now for the smart architecture for DHCP, right? So as you know that, right? So to manage the DNS DHCP server, it's strongly recommended you use smart architecture. Is it okay? Right? So let's see what are the predefined smart architecture you have in Efficient IP, right? For DHCP. Oh. So yeah, you have a single server. A single server really is for if you only have one DHCP server. See that? Yeah. You can create a smart architecture with a single server, and then you just add the single server as a member, and you manage it from a smart architecture. Are you clear with that? Right? So that is for single server. Definitely, these have no high availability. If the DHCP server go down, no more IP will be listed to the client. See? Because single point of failure. But you can manage a single server from a template. That's why you have a single server architecture. Yeah, smart architecture. In the future, if you want to expand, if you want to scale, you can change the single architecture. You can change the single smart architecture to other architecture on the fly. Okay, that? Yeah. So you can change it in the future. If you intend to scale with more DHCP server. Oh, the concept is just like DNS, right? Now, yeah. So if you want to have a high availability architecture for DHCP service, right? So at least you should, you should have a one-to-one architecture, one-to-one architecture. So if you're using the one-to-one architecture, you will have two DHCP server, two, or one master, okay, one backup. Is it okay? Or you can say one primary, one secondary. Are you clear with that? Right? So between the primary and the secondary, right? The two server, there is a failover channel. The purpose for this failover channel is for keep alive, heartbeat. So that the primary and the secondary can detect failure because heartbeat. So they detect each other heartbeat. When there's no heartbeat, then they will know, okay, the primary is down, the secondary is down. Right? So that is the failover channel. Oh, yeah. So the smart architecture will automatically set it up for you. Oh, so there's a failover channel for heartbeat. Now, the primary and the secondary DHCP server, both of them will offer IP to the client. They will offer. So it's an active. Or by default, it's active, unless you want to change it to active standby. So they are active. They can lease IP to the client. Okay, that right? So there is a high availability architecture for DHCP, one-to-one. Okay, yeah, the template do it for you. You just have to add the DHCP server to the template as a member. Or assigning the role, primary, secondary. See? Yeah. So that is the one-to-one architecture. Oh, now, of course, if you have multiple sites, right, and you want to use the DHCP service on the different site, then you can use one-to-many architecture. Oh, so let's say, for example, you have a one-to-one architecture. Oh, sorry, for example, you have a one-to-one DHCP server inside one. You have a one-to-one DHCP server inside two and site three. Oh, yeah. But the only thing is you are sharing a single master. See? That's why it's called one-to-many. So here I have a DHCP service for three sites. Right? Yeah, maybe data center one. Maybe, yeah, different region or different data center, correct? So data center one, DHCP server, data center two, DHCP server, data center three, DHCP server. So all these three sites, they are sharing a single master. You see that? One-to-many. Oh, so you have the master for site one, the backup of site one. So there is one-to-one failover channel. Or you have a master for site two, you have a backup for site two. So there is another one-to-one for site two. Okay, then you also have the master for site three and the backup for site three. The master is the same physical server. Okay, yeah. So it's a one-to-one architecture, just that you want to share a single master for multi-site. Are you clear with that? Yeah. So again, of course, the main thing here is you can share the master. You only need one master server, and you can have different secondary that is on different side. Or split scope, not used already. I mean, we won't use it anymore. Is okay? Split scope basically is yes, you have two DHCP server. There is no failover channel. So they won't keep alive. They will not detect heartbeat. The only thing is 20% of the 20% of the IP address will be offered by one DHCP server. 20% of the IP address will be offered by one DHCP server. 80% will be offered by another DHCP server. So basically, it's like you set up two independent DHCP server and offer different range of IP in the same subnet. See? So maybe a range of IP address 1 to 200 will be offered by DHCP1. Right? Yeah. The range from 201 to 254 will be offered by DHCP server 2. Like this. Standalone, independent, just offer two different range of IP from the same subnet to different client. See, normally last time we do that, especially like in Microsoft last time. Yeah, split scope. But today, most of the time we will use one-to-one. Okay, that now if you want to enable the integration between DHCP and IPAM, if you want to turn on the replication or integration from DHCP to IPAM or from DHCP to DNS, right? If you want the global DDI, you must use the one-to-one architecture. You must use the one-to-one, either one-to-one or one-to-many, because they need the failover channel. The failover channel for DHCP is required, is mandatory, right? It's required for integration from DHCP to IPAM, from DHCP to DNS. Okay? Fine. So now, right, you can add your smart architecture now. So after you add the DHCP server, now you can add the smart architecture. You can do it in any order, right? So here is just that they add the member, they add the DHCP server first, enroll first, and then you add the smart, right? Yeah. So yeah, so same thing. You just have to go to the add button, select smart, and then now you can pick the smart architecture. First of all, give a name, right? Same recommendation. Use the keyword smart as the name so that you know that this is the template. This is not the DHCP server. Okay, so that's why they put smart DHCP. Just now, yesterday, you see, right? They put smart NS because it's for name service, smart name service template. This is a smart DHCP template, right? So once you click on once you type in the name, click on next, then you pick the template, right? So in this example, they are selecting one-to-one. Okay, so when you select one-to-one, then you will be able to add the available DHCP server. So you have DHCP server 1, DHCP server 2, you can add it to the selected. Make sure you click on the plus sign. So once you have added the DHCP server to the member as a member for the one-to-one template, right? Then you pick who is the master. So assign the role. Are you clear with that? Yeah. Oh, so you can see in one-to-one, yeah, you can only have 2 DHCP server, only 2. See? And then you just pick which one is the master. Then the other one will become the backup. All right. After that, after you select the master, click on next. Then these are the settings for the failover channel. Normally we use the default. So the failover channel, as I say, is for the heartbeat, for them to keep alive. So that's why they have a port number. Or the port number for the primary, the port number for the secondary. So the port number for the primary for keep alive is 8847. The port number for the secondary is 647. Right? These are the default port number. If not required, normally we won't change it. Are you clear with that? And these are the UDP packet. Then after that, you will be able to set the the switchover, automatic switchover. So in case the primary go down or the secondary go down, the surviving DHCP will take over and offer the IP. By default, the takeover is switch off. So means that you have to manually switch over. So switch over can be manually done, or it can be automatic. So you can set the timing in hour. Yeah, the value you can set for this is from 4 hours to this hour. You see? Yeah. Fine. So if one of them down, so they will switch over based on the numbers of hours you set. Right? 0 means have to the automatic switch over is disabled. You have to manually switch over. Then the split list, you see there's a split list. The split list is for you to choose whether you want the active or active standby. So as I mentioned to you before, right? If you have a 1-to-1, you have 2 DHCP server. So if you choose the split ratio, if you choose the split list as a balance, then DHCP1 and DHCP2 server will be active, offering IP address to the client. Active, offering. Right? Now, if you choose preferred master, so that then, right, because you choose preferred master, so only the master will offer IP, right? The backup will not offer active standby. So the master active, the backup standby. See, if you choose preferred backup, then of course the backup is active, the master is standby. Your choice, you pick. By default is balanced because normally we want active. Okay with this, right? Yeah. Okay, great. So this is actually for the failover. So once you have complete the smart architecture template, then you will see the result. So you have the template now, you have the smart architecture template, and then you can see the member in the template. Same thing. The member are locked. There's a padlock for the member, means they are read-only. You cannot do the DHCP configuration on the member. So for the DHCP configuration, you have to do it on the smart. Okay, that right? Yeah. So exactly the same, right? You have the toggle button to hide the member. You have the toggle. You can click on the toggle button to display the member, so you can hide or display. Fine. Yeah. Here is to show you the failover channel. So from here itself, because this is a 1-to-1 architecture, so you know that in a 1-to-1 architecture, there's a failover channel. So if you want to monitor the failover channel, okay, yeah, you can go to the property. You can go to one of the DHCP server, you go to the property, right click property, right? And then you will be able to see there's a failover channel. So that's why they show you this is the failover channel name. To monitor the status, we will see it later. Here is just for you. There is a property that for the failover channel so that you know what is the name. Why do they show you this here? Because as I mentioned, you need the failover channel for the global DDI for the integration. Are you clear with that? Yeah. So here is just to highlight to you, this is the name to identify the failover channel. This is a name to identify. Okay. Anyway, the name is very simple. Failover channel, then followed by the smart architecture name. Okay, that. But anyway, you can view it under the property of the server. Okay. Now, here is to explain to you, okay, how it works for 1-to-1 architecture. How it works. Right? This is transparent to you. This is transparent. You just have to create, you just have to use the smart architecture one-to-one to manage the 2 DHCP server. Right? You don't have to care about how they do it, but they will do it. See? But here is to give you the back-end understanding how it works. So here, now, you know that in a one-to-one architecture, you have a primary and you have the secondary. Or another word, you have the master and the backup. Okay? So when you have a one-to-one architecture, fine, the range of IP to be offered to the client are split into half. So let's say, for example, you have a range of IP from 1 to 254. Right? So if a range of IP for the subnet, there's from 1 to 254. Fine? So they split it into half. Are you clear with that? So it means that, for example, 1 to 128, right, is for DHCP server 1. 129 to 254 is for DHCP server 2. They split the range of IP to be offered to the client into half. Right? So half will be given to the primary, the other half will be given to the secondary. So the range of IP to be offered are split equally between primary, secondary. Understand? That's why you see the green and the blue color. This is the equally, that is actually the range of IP to be offered. Are you clear? Fine. So now the primary and the secondary will be able to offer the IP, different range of IP to the client. So now you have two active server, active DHCP server, you have two active one to offer. So who will offer to a single client? Which one will offer to a single client? You cannot have both DHCP server offer to the same client. Is it okay? Yeah. So in this active architecture for offering IP, right? So they have to determine which one will offer. So for them to determine which one will offer, okay, when the primary and the secondary DHCP server receive a discovery packet from the client. So you can see the client send a discover message. So this discover message is a broadcast message. It's a broadcast. If you're familiar with DHCP, you know that. A discover packet can normally is a broadcast packet. Okay, so when the client broadcasts a discovery message, both the primary and the secondary DHCP server will receive it. Then who will offer? Okay, so now it depending on the MAC address of the client. So when the client send the discover message, the client will include its MAC address at layer 2 header. So you have a source MAC address, you have a destination MAC address. The destination MAC address is the broadcast address. The source MAC address is the client MAC address. So when the server receives the discover message, they will know the MAC address and they will use the MAC address of the client to perform a hash. You see, Pearson hash. So they hash the MAC address. The hash result will be a value that is from 0 to 255. So when both the server receive the MAC address, they hash it, they will get a common hash value. It will be the same hash value on both servers. Right? The hash value is a number that is from 0 to 255. Okay? Now, when you configure the one-to-one architecture, remember there is a split list. Okay? So by default, the split list is a balance. By default, remember we configure this thing here. See, when you configure the smart architecture, you can choose the split list, balance, or preferred master or preferred backup. See, so if this split list is set to be balanced, example, the index is 124. sorry, 128. Oh, so means that if the hash value of the MAC address of the client MAC address is a number within the range of 0 to 128, then the primary will offer the IP address. The secondary will not. But if the hash value of the client MAC address is higher than 128, right? That is actually from 129 to 254, sorry, to 255, then the secondary will offer. The primary will not. See? So they use this mechanism for active and which one will offer. Are you clear with this? So that's why the split list is configurable. You pick one. You want active standby, then you choose preferred master or preferred backup. So you can see when you choose preferred master, right? The index become 255. So means that from 0 to 255, it will be the master to serve it. So means that all discovery message will be served by the primary. Okay with this? Understand? No. So as I mentioned, this is for your understanding the back end, right? It's good for troubleshooting. Okay, that right? And yeah, and it's also good to understand this, especially when you need to troubleshoot and read the log, right? Okay, good. Now, you know that the failover channel is a keep alive. So there are different state of the keep alive. Sorry, there are different state of the failover channel. Okay, that right? So the state of the failover channel will change definitely when there's a failure. Or when there's a failure, when there's a recovery. You get what I mean? Right? So yeah, so these are the three failover channel state. Normal, communication interrupt, partner down, recovering. Understand? So these are the failover channel state. Right? So let's have an understanding what does it mean. Okay, now definitely when everything's are healthy, the failover channel state will be normal. Isn't it? So you will see the state failover channel normal. Fine. Now, let's say an incident happened now. Let's say the backup go down. So means that DHCP server 2 down. Right? So you know that they keep alive, right? Yeah. So they do keep alive. So now the primary will know that the secondary is down. So that's why the communication, so that's why the failover channel state go to communication interrupt. Because the primary never receive heartbeat. I never hear the heartbeat from the secondary. See? So that's why you have this failover channel state change to communication interrupt. During communication interrupt, right? The surviving DHCP server will offer all the IP. It will offer all the IP. It will renew all the IP. Right? But the only thing is they set the lease period to 1 hour. Shorter. Normally when we lease like few hours or days. Right? Yeah. So during a communication interrupt, the surviving DHCP server will offer all the IP and renew all the IP, just that with the lease duration of 1 hour. Shorter listing period, so that the client can come back and renew the IP. Hopefully, the fat DHCP server have recovered. Understand? Yeah. So now, from communication interrupt, okay, so although the failover state is communication interrupt, but the DHCP service is not interrupt. The DHCP still the DHCP server still offer IP address. Right? Now, of course, then it will go to, okay, now another thing I forgot to mention. Now look at the range of IP. Remember the range of IP to be offered by DHCP is split equally to half-half. Okay, so during the communication interrupt state, they still maintain, you can see the range of IP is still equally split into half-half. So the surviving DHCP server will only offer the IP address that is within its range. That is within its range. Okay? Yeah. So now, from communication interrupt, right, it can be switched to partner down. Switch to partner down. You can manually do it, or remember there is a switchover timer you can set in hour. So if you set the auto switchover, turn on the auto switchover specifying the numbers of hour, then it will be automatically switch over now to partner down. If not, you can manually do the partner down. So when the failover channel is in the partner down state, okay, the surviving DHCP server now will own the full range of IP. It will own the full range of IP, and it will offer the IP from the entire range. Right? Yeah. Fine. Because if you don't go to the partner down, the IP address offered by the surviving DHCP server might run out because they only have half the IP address to offer. See? During communication interrupt. Right? So it's only when it's a partner down, the surviving DHCP will own the full range of IP address now and offer from the full range. Are you clear with that? Yeah. So that is the partner down. That's why that is one of the reasons why you want to manually switch to partner down. Because the IP to be offered is running out. Okay, that's why you want to change to partner down so that the full range can be offered by the surviving DHCP server. Right? Yeah. So now, when the fed DHCP server come out, so it means that you have repair, it come back, then from partner down, it will be automatically switched to recovering. So this is the intermediate state. Intermediate. Are you clear with that? Right? And after that, from recovery, it go back to normal. So this is the failover channel state. Oh, so how do you check the state? So to view the failover channel state of the DHCP, you can go to old server, Chevron, click on the Chevron, and then you can see the failover channel. And then you will see the channel here. Yeah, the failover channel here. So, right? So you have the primary, DHCP server 1 is a primary, DHCP server 2 is a primary for the failover channel, the port number they use to communicate for keep alive, right? And the state is normal. See? Yeah. So that is the state, normal state now. Oh, so now, scenario 2, the DHCP server 2 is down. Right? So when DHCP server 2 is down, if you look at the state now, communication interrupt. Are you clear with that? Right? So for DHCP1 detect there is a communication interrupt. Right? Because why? The DHCP server 2 is down. Okay with this? Right? You can also view, you also have this multi-status. You can mouse over it, you can see. They will tell you what is the reason. So this is one way you can look at the status of the failover channel. You go to the failover channel of the server. Understand? And you need to click on the Chevron. Okay? Yeah. Okay, now you can also view it under old server. You can see if you are not using the failover channel, you just have to view the older DHCP server, right? Under the server listing, you also have this multi-status. So if you mouse over the multi-status, you will be able to see communication interrupt. One is communication interrupt. Oh, yeah. The different color, you see that? Yeah, they will tell you is partner down, recovering. Oh, anyway, look at the multi-status code. This is a multi-status code. So on the server listing, you will have the multi-status that indicate what are the current state of the failover channel. Right? And you also can see from here, you realize that on the management server, the management server cannot reach DHCP2. Okay. Timeout here means the management server cannot reach DHCP2. It may be, yeah, DHCP2 is down. Are you clear with that? That's why there is a communication interrupt. Understand? Okay, good. So you have a lab to work on this. This is also a very simple lab. You just have like what you have done for DNS. You're going to add DHCP server 1, DHCP server 2. After that, you're going to create the smart architecture, and you're going to use one-to-one. And after that, you're going to add the member, and you pick the master. DHCP server 1 will be the master. Understand? Yeah, that's what you need to do. Fine. So pretty straightforward. Yeah, I'll give you 10 minutes to do that. Right. So we're going to start again at 11:10. Right. Yeah. So in Jakarta will be 10:10. So work on the lab. Feel free, if you have any question, please feel free to ask.